Good evening. My name is Trevor Will with Aviation Safety and Security. I'm in this course, I'm in this class. Love being here. And I've had the opportunity to research and present to you today a presentation on the advancements in air traffic control systems. We'll be exploring a little bit about air traffic control systems and navigating the future of aviation and the future of air traffic control. You'll see why I said the future of aviation rather than just ATC here in a second. But I really am excited to share this topic. It's something I've gained a lot of interest in while researching, and I hope you enjoy. Um, Air traffic control is, as we know it, or as I know it, I'm a pilot, and it has been extremely beneficial to me as just a general aviation pilot. I'm a flight instructor here at the school. I teach people how to fly, and air traffic controllers are a huge aspect of that. They really are the backbone of aviation. Sure, you can get up and fly, and you get some drone pilots that have never talked to ATC. Here at Logan, we don't necessarily have a tower. We can go up and fly, but when it comes down to air transport or traveling long distances or any of that, air traffic control is unbeatable. It is really a huge aspect of aviation, and without them, we really could not have the absolute scale of air transport that we have today. I mean, going into that, we talked a little bit about the importance of air traffic control systems. Um, and I think it's important to note as well that they really began with very little. Began with radios and notes, and air traffic control started back in the 1920s and was explored by the U.S. in the 1930s. And of course, we'll get into that a little bit as well. But we'll be talking about the history, the overview of air traffic control, the history of it, some challenges and concerns with air traffic control currently and moving forward, and how we can overcome those in the future of air traffic control and aviation. So the overview of air traffic control systems, we'll skip past this page here, but where did ATC start? That's a huge question that I think a lot of people have a good concept of, but very few have a very detailed understanding of. Now, given the time constraints that I have on this presentation, I'll keep it as straightforward as I can, but I really do encourage you to look it up and get into it a little bit, because it really is interesting, and gain a huge appreciation for where we're at today. Anyway, ATC began in the 1920s. The first air traffic control station was in London, and that was really the first human interaction of ATC there. I mean, there was a station. There were people in there talking on the radios, writing down notes, putting them on paper, bringing them to stations, and it was really good because there were airplanes with radios that could talk to ATC, that could talk to each other. But of course, there were a lot of aircraft, a lot of pilots that were slow to put radios on their planes, and so there was a little bit of a challenge there. It's really impressive controllers back in the day, and they did not make near as much as what our controllers make today. Even before that, though, there was some form of air traffic control and air routing. When the advent of airmail, just a few years here in the U.S. after the Wright brothers began exploring aerodynamics in aviation, there were arrows put on the ground at certain points or waypoints for airmail pilots to know which direction to travel and at what point they get to their destination. Really incredible pilots, and seriously, they've come a long way since there. Now, that was in the 1930s. I should say in the 1930s, Cleveland, Ohio was the first U.S.-based air traffic control station. Now, this picture, I'm not sure that's in Cleveland, but it is 1936, and that's what it looked like. Just small rooms with glass windows and a lot of radios and a lot of paper. It's unbelievable to me. In the 1970s, we came up with and started implementing Mode C transponders. Mode C transponders are very important because they place an identification on each aircraft on the radar screen. Before Mode C, most radars would only show a blip on the screen, and you could guess based on radio transmission where different planes were and what time they were getting to a certain area and where they should be, but it was very difficult to tell exactly where they were. Mode C transponders changed all that, and we still have them in all aircraft. Not all aircraft, but a majority of the aircraft that fly today because of the requirements that they need to have in order to travel into, say, restrictive airspace, not necessarily restricted, but more controlled airspace. And then in the 1980s, ADS came to be, but we'll skip over the 1980s and go right to 2000s. In the early 2000s, ADS-B became a big thing, and ADS-B went from being a radar system to a satellite-based system, basically giving you a little GPS waypoint for the controllers. We're lucky here that we get ADS-B in on our DA4s we fly over the airport, where we can receive the ADS-B out that most planes are required to have today. But we're able to see altitude, climb rate, direction of flight, XY axis. I mean, seriously impressive information. There has been some controversy around it because it also gives registration, where it was registered, who it's registered to, where the aircraft is based out of. If you've ever seen the Flight Radar 24 application, all of that is ran off of ADS-B. So it is a really very impressive technology, and I'm certainly glad that we have it, as well as ADS-B in our aircraft. Some challenging air traffic control, and before I start, I'd like to point out this picture here. This is a modern air traffic control tower, highly advanced from where we saw the last slide. Some challenges in air traffic control are interesting, especially since COVID happened. There's been a huge jump or a huge spike in air travel and aviation in general, and that spike has been a huge challenge for traffic controllers. Granted, I'm from Houston, and now I fly over Salt Lake, and it seems like Salt Lake is just slammed with aircraft traveling, and to the point where they have a hard time transitioning us sometimes from one point of the airspace to another. Very, very, very busy. Now, airspace, their number one prerogative is to ensure safety in air travel. They give you separation. They set you off on instrument approaches that allow you to fly in the clouds. That's what they do, is they provide safety. And so it's very difficult to do as airspace continues to get congested. So that's combated by the use of satellite-based systems, GPS, ADS-B. It's done a very good job at helping controllers navigate this congestive state that we're in. But it is a change still. Older controllers are used to older infrastructure, and some of that older infrastructure in itself is going away. And so we have overlapping navigation systems. We've got overlapping navigation systems and overlapping knowledge between different controllers, newer controllers, older controllers, and provides a sort of gray area that is inherently hazardous. But there's been so much work put towards air traffic control that has decreased those hazards. That's not to say those challenges don't still exist, but they are being dealt with effectively. Along with a lot of this GPS and satellite-based navigation, we have a problem with cybersecurity. There have been somewhat recently spoofing of GPS waypoints. So many aircraft today, especially newer aircraft, Embraer, Airbus, even newer Boeings, that rely on GPS and radar, or excuse me, GPS and satellite-based information to provide pilots with the appropriate navigation waypoints, ultimately. And there's been some issues with some spoofing, some hacking, some cyber attacks. So there's been a huge implementation of cybersecurity, including network segmentation, encryption, and machine learning algorithms. Excuse me, we're talking about AI, which also helps controllers in the tower and in different centers. And I'd briefly like to talk about NextGen. NextGen isn't necessarily a cybersecurity deal, but it goes into, again, satellite-based navigation. NextGen is a current system that's being pushed out by ATC, or excuse me, by aviation industry, I should say, that benefits ATC, benefits aircraft, and what it does is it routes aircraft into a highly effective or efficient routing process. It allows pilots to begin a descent, and instead of having step downs, which is a little bit hard to explain right now, so I'm trying to keep it vague, instead of having step downs where they have to descend and level off and descend and level off, they can begin atop a descent at 30, 40,000 feet, wherever they're at, and have a constant descent all the way down to the ground. It also decreases their routing and decreases fuel use, decreases noise volumes. It's a very, very impressive system. Again, don't have too much time to go over that today, but I seriously encourage just researching it yourself and checking out NextGen. It's a really impressive ATC implementation that we have going on right now as we speak. Air traffic management in emerging markets is very, very interesting as well. There's growing air traffic volumes across the world. It's not just here in the States, across the world. And that includes places like rural Asia, Africa, or Latin America, where there's high volumes of air traffic for whatever it may be, tourism, business, and these countries are having to adapt to more advanced air traffic control systems. So they're investing huge amounts into satellite-based navigation systems, ADS-B, and not necessarily because they want to, but in order to really bring more people in and increase their financial capabilities, they have to invest in those things. So across the world, there's an emerging market with ATC. New technologies in ATC operations besides NextGen, one of them is remote tower technology and new CDM frameworks. Remote tower technology is essentially remote towers. London City Airport has these towers. It's fully remote tower with a bunch of, I forget the number, but a bunch of high definition cameras and sensors that allow ATC to look outside without actually being there. There are some regulatory and policy challenges that also remain a struggle with air traffic control and bringing new advancements in technology to air traffic control. You see that with aircraft. When aircraft technology gets brought to the market, generally it's about 10 years old by the time, 10 to 15 years old by the time it gets there, because of all of the paperwork that gets brought up in different testing systems and those sorts of things that can really hinder progress and innovation. As the ATC continues, we look at huge amounts of innovation and investment. There is pressure on the existing infrastructure and airspace to continue to advance, but I believe we're prepared to meet those evolving demands. I think that there's been a huge advancement in ATC up to this point, and it's my belief that we'll continue at a very rapid rate for the safety of aircraft, for the safety of people on the ground, people in the air, and the efficiency of aviation overall. I'm very, very confident that that aviation will continue to progress as it has, and we'll all be able to see some incredible advancements within our lifetime. And we look at the 1930s when the first air traffic control tower center opened in Ohio. It's been less than 100 years since then, and so we can certainly see huge advancements moving forward. Thank you so much for listening to my presentation. Left my name, phone number, and day number on there. If you'd like to reach out to me, please do. Ask some questions. Good day.